Hello, everyone. At the top of my page here, you can see the example given by Evan Dummett. Now, his bilinear form is defined by phi of VW on A is equal to V transpose AW. Now, V and W are vectors in Rn, right? And the metric A is a square metric and it consists of real value entries. Now, he selected the metric E is equal to 1, 2, 3, 4. He arbitrarily selects that because you can use any metric, any square metric with real value entries for this one here. So working this out, phi of VW on E, we write back here V transpose, and that gives us the 1 by 2 metric x1, y1. Then we place the metric A again, which happens to be 1, 2, 3, 4. And then we place our W, the vector W. And working all of that out gives us here x1, x2 plus 2x1, y2 plus 3x2, y1 plus 4y1, y2. Now, my idea in concretizing or fleshing out the theorem, right, that states that the sum of two bilinear forms is another bilinear form, is to fashion a bilinear form similarly to what Damet did here at the top and add the two up and see what the result will be, right? Now, I'm going to define my bilinear form of y on y of VW on B, right, is equal to V transpose BW. Now, B, I'm going to arbitrarily select B as the identity metric, right? Real value entries there, yeah, 1, 0, 0, 1. And I'm going to do the simplification where I have to find V transpose. V transpose, since V is a vector x1, y1, you transpose that, you have the 1 by 2 metric x1, y1. And this here, we have it here, the next item to place here is the metric, which I stated as B, 1, 0, 0, 1. And then next thing is the vector W, x2, y2. And working all of that out now, gives the result here, x1, x2 plus y1, y2. Now, did I say this here, my bilinear form is defined by y of VW on B? No, it shouldn't be that. That's not y, right? Sorry about that. That's if I said that, sorry. That's gamma of VW on B, right? Gamma of VW on B. Now, so I have my bilinear form at the back here. It's x1, x2 plus y2, y1. Now, let's see if I can add the two up and get a linear map, right? So using Evan Dummett's bilinear form phi of E plus the one that I made up, gamma of B, I just do the simple addition, phi of A terms here, and then gamma of B terms at the back here. Now, adding all of that up gives me this result here, 2x1, x2 plus 2x1, y2 plus 3x2, y1 plus 5y1, y2. And you see, if you arbitrarily select two vectors uv or vw with Rn entries, right? You can substitute the values here, and you can see you'll get a linear map. You'll get a scalar as your answer, no matter what the two vectors are, just as long as they consist of entries from Rn, right? So you see, yes, indeed, we have a linear map when if we select any two vectors from Rn. You see, we'll get a linear map when we substitute the respective x1, y1, x2, y2 values from those vectors here. You'll get a linear map. Okay, I hope This here lends support to clearing or helping you to conceptualize that yes, indeed, the sum of two bilinear forms is yet another bilinear form. Thank you for listening.